Hi, this is Germs. Welcome to my new podcast called Sundays Are for Science. This is a segment I like to call Science Sunday, and in this segment, viewers submit their questions. So, this question comes from Talia, and basically Talia asks, can plants grow in artificial light alone? I also really love this question because I'm kind of obsessed with wavelengths of light. So you've probably heard of RGBIV, the colors of the rainbow. Well, the short answer to your question is yes. Plants can grow in artificial light alone. Different plants have different light requirements based on their makeup. As a result, it would depend on the wavelengths of light that are being produced by that light source. To answer your question, I think it would be helpful to address why the sun is such an effective source of light for so many varieties of plants to grow. And the reason why is because the sun actually produces a white light. So if you know anything about light, white is at one end of the spectrum, and then black is at another end of the spectrum. So let's talk about white light. The sun produces white light. Anything that produces white light produces every wavelength of light within the visible spectra. The reason why this is important, it can service a wide variety of plants in order to give them their light needs. Because the sun is so effective at doing this, we have to address what kind of light are you talking about when you talk about artificial light. Because if you're talking about a white artificial light, the more white the light is, the broader the range of and wavelengths of light, and the broader the range of plants that it can service the needs of. In certain specific cases, there might be a plant that needs blue light. And so you can actually get a light bulb that produces just blue light. But most plants need a combination of lights, but you can also get a bulb that produces a wide range of wavelengths, or you can just get specific bulbs that produce a certain wavelength of light that will be most effective in producing the light that that plant needs. And then also you don't have any wasted energy, because if you're producing wavelengths of light that that plant is not responding to and is just reflecting off of its surface, then you're wasting energy. And so if you can get a wavelength of light for your bulb that addresses the needs of that plant, then you conserve energy. So the answer to your question is it depends. It depends on which wavelengths of light that bulb is producing, and then also which wavelengths of light the plant responds to. And so the best way to address this without having to do so much research into all the different plants, so if you wanted to grow a bunch of different plants which have different energy needs, then you might want to get a bulb with white light, which produces a broader range of the spectra and would be more effective in growing plants from an artificial source, and it would be more close to treating them with sunlight. Thank you for that question, by the way. So this next question comes from Saki. Really, this question is a little similar to Talia's question. Just to expand on the principle of light, we talked about white light and how white light produces every color in the visible spectra, right? So plants have little filaments, whether it's chlorophylls, xanthophylls, and other filaments that actually absorb light, and they absorb characteristic wavelengths of light. And any light that they don't absorb, they reflect. When the plant reflects this light, that is what you see. So if a plant reflects green light, it's because the plant is not processing that green light. It's not absorbing that green light, it's just reflecting it. It takes every wavelength of light that its fills can process, and then it rejects everything else. So the combination of all of those wavelengths of light that are rejected by that plant turn out to be green in most plants, which corresponds to the fact that most plants are green because those plants are not utilizing that green light. So when we talk about roses, the rose's color corresponds to which wavelengths of light that that plant has rejected. And so the reason why you probably wouldn't see a rose that's naturally blue is because that the filaments in that plant are not rejecting that blue light, because the blue light is so vital to that plant that it's absorbing it rather than rejecting it. So if a rose appears red or green or purple, it's because that those wavelengths of light are not being accepted by that plant, and then that's what comes back to you because it's reflected. And so that goes with any object. If you look at any object around the house, or you look at the sky or anything, the reason why you see all of these colors, these are the colors that are not being absorbed by that material. You might have heard that black, the color black, absorbs every wavelength of light. And so there's this void. So basically, because the color black is absorbing every wavelength of light, in theory, no light is being reflected back to you, so it appears black because all the colors are mixed together. And if you've ever played with paint as a kid and you mix all the colors together, the more colors you start to, when you start to mix in those darker colors, it appears to be black. And that is because black is just a mixture of every color. And then white is the reflection of every color. So anytime something is reflecting every wavelength of light, it appears more white. And the more wavelengths of light it absorbs, it appears more black. So the answer to your question is that it's likely that roses need blue light, and because they need blue light, they are not going to reflect that blue light, and therefore they won't appear to be blue. Thank you for that question again, Saki.